Hey everyone, today we're going to learn a little more about factoring polynomials. First thing I want you to do is I want you to simplify, in other words, multiply these two factors. When you multiply them, we'll use a Punnett square, so multiply it out, we get x squared, negative 5x, and negative 25. When I write all of those out, we notice that the middle two terms subtract out. So we get just x squared minus 25. And what happened that's unusual? Well, it doesn't always happen, but in this case, we have no linear term. So if I say, hey, well, factor x squared minus 25, you could go through the whole rigmarole of, let's see what adds to 0, because 0 would be b, and multiplies to negative 25. Or you could just look up and say, hey, we just did that. That would be x minus 5 times x plus 5. So the question is, when does this happen, and how can we use this to our advantage to pick these up easily? And the answer is, this happens when we have a difference of squares. In other words, the first term is squared, see x squared. The second term is squared, 25, and right between is subtraction. When that happens, when we have subtraction of two different squares, then that means we can factor it using this shortcut method. Let's try this on a practice problem here. Down here I've got x squared minus 100. They're both squares and there's subtraction between them, so I can put the parentheses there. I'm going to write down the square root of the first one, which is just x, in the first spot of both of the parentheses. I'm going to write the square root of the second, which is just 10, on the second spot, and I'm going to put one addition sign and one subtraction sign. And if you want to check that, you'll notice that the linear term will add up to 0 again, and we get x squared minus 100. I'd like for you to try this one on your own. Go ahead and pause the video and try that. Alright, let's look at a slightly different looking one. This next one, b to the 6th power, is actually something squared, okay? 49 is 7 squared, but b to the 6th, what is that squared? Well, I'm going to write my parentheses, but I have to remember that b to the 6th is the same as b cubed squared. So the thing that I'm going to put in the first spot of both of the parentheses is b cubed, since b cubed squared, in other words, b cubed times b cubed equals b to the 6th. The last spot I'm going to put the 7s, because 7 squared is 49, and I'm going to put one addition sign and one subtraction sign, and I'm done. This last kind of problem I'll show you is, again, 4x squared. That is something funny squared, but it is a term squared. It is 2x squared. So I'm going to put my parentheses. I'll put 2x in the first spot, and you can check, make sure 2x times 2x is 4x squared. And I'm going to put 3 in the last spot and just put an addition sign, a subtraction sign, and then we are done. I'd like for you to try these two. One hint or a heads up warning is that last one you can actually, well, I'm not going to tell you exactly how to do it, but I'd like for you to look for it. My hint is that your final answer should have 3 binomials. And if you can do the first step and get stumped on the second step, don't beat yourself up over it. I'm sure someone in your class will be happy to show you. All right, let's move on and talk about finding the greatest common factor first. Whenever you're factoring a trinomial, sometimes it's easiest to look for the greatest common factor first. For example, right here, at first glance, it looks like a is not 1, and it looks like a very difficult factoring problem. And we'd have to start playing with factors, but if you notice, all 3 of those terms, all 3 of the coefficients, we can factor out of 5. So that's what I'm going to do. I factor out of 5 first, and what is left behind is x squared plus 2x plus 1, and that is a much easier problem to factor, an easier trinomial. As you know, we can just say, hey, what adds to 2 and multiplies to 1? That would be 1 and 1, so we get x plus 1, and x plus 1 is that trinomial factored. So just as a heads up, just look for the greatest common factor first before you give up because it's a harder problem. Let's try some of those down here. With 3x squared plus 6x plus 3, I'm going to notice I can pull out a 3 and I get, well, the same trinomial, so I'll leave it to you to finish the problem. You do need to factor it completely, so we're not done yet, but I'll let you do that part. On this other problem, this is not 2x squared. That is not a perfect square. However, when you pull a 2 out of both of those terms, now we do have a perfect square. So just like we did earlier in the video, both of those are squares, so we have a difference of squares, and I will let you practice factoring that out again. So once again, we're not done. You have to finish factoring it. Down here at the bottom, I'd like for you to try these two before coming to class, and thank you for watching this video.